Today we are discussing fuel technology. Fuel is a combustible substance which on proper burning in presence of oxygen or air gives a large amount of heat energy that can be converted and used for economically, domestic and industrial purpose. So fuel react with oxygen which produce products and heat energy. So fuel is a combustible substance containing carbon as a main component, which on proper burning gives large amount of heat which can be used economically for domestic and industrial purpose. Examples: wood, charcoal, coal, kerosene, petrol, diesel, producer gas, oil gas, etc. So during the process of combustion, a fuel, that means coal, the atoms of coal containing carbon, hydrogen, oxygen, etc. combine with oxygen with the simultaneous liberation of heat at a rapid rate. This energy is liberated due to the rearrangement of valency electrons in these atoms, resulting in the formation of new compounds like water molecule and H2O. These new compounds have less energy or heat content in them, and therefore the energy or heat released during this combustion process is the difference in the energy of the reactants. That means fuel reactor, oxygen which gives products. In that they having carbon, hydrogen, oxygen, etc. So that products of having less heat content. Formation of the product, at the same time they release less heat content. So here we see the simple reaction. Fuel react with oxygen and produce heat. So similarly, carbon react with oxygen which gives carbon dioxide plus minus 94.1 kilocalorie mole heat energy, moles heat energy. Hydrogen react with oxygen which gives water molecule. At the same time they liberate minus 67.4 kilocalorie per mole. The main source of fuels are coals and petroleum oils. So these are stored fuels available in the earth crust and are generally called as a fossil fuels. So this is the introduction about the fuels. Then we go for a classification of fuels. The fossil fuels have been classified according to their occurrence and the state of aggregation. So according to the aggregation, fields are classified into two types. So one is primary fields, the next one is secondary fields. So coming to first one, primary fields. These fields which are found in nature, as such fields are known as natural fields and primary fields. Examples: wood, peat, coal, petroleum, and natural gas. The next one is secondary fields. Secondary fields are those which are derived from the primary fields. Secondary fields are derived from the primary fields. Examples: charcoal, coke, kerosene oil, diesel oil, petrol, coal gas, oil gas, producer gas, so etc. So these are the secondary fields. Then flowchart, chemical fields. So chemical fields were classified into two types based upon the occurrence: primary fields and secondary fields. So primary fields, state of aggregation, are again classified into three types: solid fields, liquid fields, and gaseous fields. So these three fields are primary fields. So coming to first one, solid fields. Examples: wood, peat, lignite. So coming to liquid fields, example: crude oil. The next one is gaseous field, example: natural gas. So these three fields are occur in nature, are available in the nature. So that's why it is called as a natural fields or primary fields. Next we go for a secondary field. Here also secondary fields can classified into three types based upon the state of aggregation. So one is solid, second one liquid, and the last one is gaseous fields. So these three secondary fields are derived from the primary fields. So these secondary fields is also known as artificial fields. So that means this artificial solid field is derived from the natural solid field. Similarly, same, the liquid, that means the secondary liquid fields are derived from the primary liquid fields. Let's see the examples. Solid fields, examples: coke, charcoal, petroleum, etc. So liquid fields, examples: tar, diesel, petrol, kerosene, synthetic petrol, fuel oil, gasoline, and then LPG gas. Next, the last one, gaseous fields. Examples: water gas, oil gas, coal gas, so etc. Next, we go for classification of fields. Classification of fields. So that is earlier we discussed the classification of fields. Next, we go for characteristics of a good field. Characteristics of a good field. A good field should possess the following characteristics. So let's see what are the good characteristics of a field. So let's see the field which should having higher calorific value. Fuel should possess a higher calorific value. So, what is meant by calorific value? Calorific value of a fuel is the total quantity of heat liberated from the combustion of a unit mass of the fuel in air. So that is known as calorific value. So once again I am reminding, calorific value of a fuel is the total quantity of heat liberated from the combustion of a unit mass of the fuel in air. So that is known as calorific value. So here the fuel should possess a higher calorific value. So that means a good fuel should possess high calorific value, which results in the liberation of amount of heat for 1 unit mass or volume of the fuel. So that means the liberation of heat amount for unit mass of a fuel is known as higher calorific value. Next, so it should have less moisture and ash content. An ideal fuel should possess low ash content. An ideal fuel should possess low ash content. So the moisture content of a fuel reduces the heating value of the fuel. Hence, a good fuel should possess low moisture content. That means the fuel should have less moisture and less ash content. So otherwise, the coal sample may having more moisture content, which reduces the liberation of heat energy. So that's why you should have less moisture and less ash content. Next one, a fuel should have moderate ignition temperature. So next, the velocity of the combustion should be moderate. Here a good fuel should possess moderate velocity of combustion. Whenever the fuel have moderate velocity of combustion to prevent the loss of heat by radiation. So which prevent the loss of heat by radiation. So that is the moderate velocity of combustion. So you should be cheap and readily available. The cost of the fuel should be low and easily available. It must be easy to handle, store, transport. Already we discussed minimum cost. The fuel should be easily handling, easily store, easily transport. Combustion of the fuel should be easily controlled, while burning the fuel easily controlled. You should not produce any undesirable products like toxic gases. So fuels are used to generate energy in the form of heat. Already we discussed some of the industries like nuclear power plants, thermal power plants, hydroelectrical power plants. They were using fuel. The fuel will burn and the heat energy will convert it into electrical energy. At the same time, they discharged hazardous waste to the environment. So that hazardous should not be as a toxic gases. So next, you should have higher calorific value, higher carbon content. The fuel may having higher carbon content automatically, which produce higher calorific value, which yields higher calorific value. So these are the some good qualities of a fuel. So next we go for solid fuels. Solid fuels advantages and disadvantages. They are easy to transport and convenient to store without any risk. Already we discussed the good qualities of the fuels. But easy to transport and easy to convert, convenient to store without any risk. The second one, they possess moderate ignition temperatures and their cost of production is less. So these are the few advantages of solid fuels. So there is some disadvantages of solid fuels. They contain high ash content and excess of air is required for combustion. So non-combustible fuels may have high ash content. So it's required to burn, they require a higher excess of air for combustion. So moisture content is higher, ash content is higher, non-combustible components existed in the fuel which reduces the calorific value of the fuel, which reduces the calorific value of the fuel. Calorific value is less when compared to the liquid and gaseous fuels. So generally solid fuels having less calorific value when comparing to the liquid and gaseous fuels. So while burning the solid fuels, we cannot control the operation. That means combustion operation cannot be controlled while burning the solid fuels, while generating heat energy. So solid fuels, the example coal. So coal is a primary solid fuel which is formed from the remains of decaying vegetable matter under the influence of heat, pressure and bacterial functions under the earth crust. It is composed of carbon, hydrogen, nitrogen and oxygen atoms. Some of the non-combustible inorganic matters. So that means the coal may having the composition of carbon, hydrogen, nitrogen, oxygen and some non-combustible inorganic matter, which is composition of coal. So classification of coal. How to classify the solid coal? So let's see the classification of coal. So various types of coals recognized on the basis of rank or qualification from the wood. Here we see the wood, peat, lignite, bituminous coal, and anthracite. So firstly we are using as a wood. Further we get peat. Further we get lignite. Further we get a bituminous coal, and further we get anthracite from the solid coal. So calorific value, hardness, carbon content increases from wood to anthracite. Wood to anthracite, calorific value should be increases, hardness increases, carbon content increases. So that's why anthracite having higher calorific value than all these four coals. So volatile matter, moisture, hydrogen, oxygen, sulfur, and nitrogen content were decreases. We see the from wood to anthracite, calorific value increases, hardness of coal increases, carbon content increases. Coming to volatile matter, moisture, hydrogen, oxygen, sulfur and nitrogen content also decreases. So that means when we go for wood to anthracite, the impurities are decreases. Impurities are decreases. So we get peat is the least ranking coal, while anthracite is the highest ranking coal. At the same time, peat is the having lower calorific value. Anthracite may having a higher calorific value also. So what about feet? Let's see the discussion of feet. Feet. So it is a brown uh, fibrous jelly like moss. It is regarded as the first stage in the qualification of wood. And we get feet from the wood as a first stage. So they may having the composition of 57% of carbon, 6% hydrogen, 35% oxygen, 2.5% as. So that is 2.5 to 6% as. So they may having the 5,400 kilocalorie per kg as a calorific value. So let's see the composition of feet. Uh, next we go for lignite. So lignite may having the 60% to 70% carbon content, 5% hydrogen, 20% oxygen. They may having the calorific value 6,500 to 7,100 kilocalorie per kg. They having the calorific value. Similarly, we go for bituminous coal. So bituminous coal also may having 75 to 80%. Bituminous coal may having 75 to 80% carbon content and 10 to 20% oxygen content, and may having calorific value about 7,000 kilocalories. So earlier we discussed, we go for feed to anthracite, the composition of carbon content should be increases, calorific value should be increases. Volatile matter, ash content, some of the compounds like hydrogen, oxygen, sulfur, nitrogen, and some of the impurities content should be reduces. Earlier we discussed that. Then we go for anthracite. So anthracite may having 90 to 98% of carbon content. Anthracite may having 90 to 98% of carbon content, and may they having 8650 to 8700 kilocalorie of a calorific value. So next we go for analysis of coal. So to access the quality of coal, to check the quality of coal, we are using two analysis methods to analyze the quality of the coal. So one is proximate analysis, the second one is ultimate analysis. One is proximate analysis and the second one is ultimate analysis. So what is meant by proximate analysis? So it is an imperial analysis in ranking of coal. So rank is usually assessed by a series of tests collectively could the proximate analysis that determine the moisture content, volatile matter content, ash content, fixed carbon content of a coal. In the proximate analysis, we analyze or we determine the quantity of moisture, quantity of volatile matter, and fixed carbon we as content we determined in the proximate analysis. So next we see the so moisture. So 1 gram of powder and 8 dried is weighed in a crucible. So that means easily it is a analysis, analytical analysis methods, just like a gravimetric analysis to know the weights. So we take 1 gram of powder, dry powder, cold dry powder, taken into the crucible, and it is heated on the oven. We maintaining 109 to 110 degrees Celsius temperature for 1 hour. After cooled in the desiccator and weighed. So that is the percentage of moisture equal to loss in weight, weight of coal taken into 100. So we calculate the percentage of moisture present in the, we take the 1 gram of a powder. Next we go for volatile matter. So that is volatile matter. So here the coal powder is taken into a crucible. The crucible should be closed with the lid. The mouth of the crucible should be closed with the lid and placed in a mobile furnace. Placed in a mobile furnace where the temperature is maintained 950 degrees Celsius plus or minus 20 degrees Celsius for 7 minutes. So then the crucible is taken out, cooled in desiccated and weighed. Here also the percentage of volatile matter equal to the percentage of volatile matter equal to loss in weight due to the removal of volatile matter by weight of coal taken into 100. We know the percentage of volatile matter, we take the amount of coal powder. That we determine the content of volatile matter, whatever it may be, we take the sample of coal powder. So next we go for ash content to determine the ash content in a coal powder. So we take coal powder in a crucible, then it is heated without lid. So volatile matter we kept the lid and we heated, and after we cool the crucible and we calculate the percentage of volatile matter. Coming to the ash content, we take the coal powder into a crucible without lid, then heat it in the mobile furnace at 700 to 700 plus or minus 50 degrees Celsius for half an hour. After that, we cool the crucible and we calculate the percentage of as the percentage of as equal to weight of residue by weight of the coal taken into 100. So we calculate the as content in the taken coal. Next one is fixed carbon. So this is reported as the differences between 100 and the sum of the percentage of moisture and the volatile matter as content. So similarly, we are seen in the water technology first unit, water treatment. We calculate the temporary hardness, permanent hardness, total hardness. So permanent hardness equal to, we get some value. Total hardness, we get some value. So what about temporary hardness? So temporary hardness equal to total hardness minus permanent hardness. We get the temporary hardness. So similarly here also percentage of fixed carbon equal to 100 minus percentage of moisture plus volatile matter plus as. So we get the content of fixed carbon present in the whatever it may be. We take the coal fodder sample for approximate analysis. So next, what are the significances of approximate analysis? So we do the approximate analysis and we determine the content of the moisture, volatile matter as and fixed carbon. So while we knowing this content in the coal by approximate analysis, what are the significance? So that here, see here, the moisture, volatile matter as content lowers the calorific value of a coal. So that means higher content of moisture, volatile matter as content are existed in the coal, which reduces the calorific value. So therefore, less the moisture, less the volatile matter, less the content of as, so better the quality of the coal, which increases the calorific value of the coal. Next, high percentage of fixed carbon is desirable. It increases the calorific value and quality of the coal. So earlier we discussed fixed carbon. So carbon content is higher in the coal automatically, which produce the higher calorific value. So these are the significances of approximate analysis. Next we go for second analysis as ultimate analysis. So here we determine the elements. That's what is called as a elemental analysis of coal, used to determine the carbon, hydrogen, sulfur, nitrogen, as and oxygen content in the coal. So firstly we see the carbon and hydrogen. So we take 1 gram of coal is born in a steam of oxygen in a combustion tube. Carbon and hydrogen of the coal are converted into carbon dioxide, water molecule respectively. These products, carbon dioxide and water molecule, are absorbed separately by KOH and calcium chloride tubes known weight. So we are using calcium hydroxide and potassium hydroxide and calcium chloride. We'll use it to absorb the carbon dioxide and water molecule products formed in the tubes. So the calculate the percentage of carbon, so that is increase in weight of potassium hydroxide by weight of the coal sample taken into 12 by 44 into 100. So 12 is the mass of the carbon, so molecule mass. So we get the percentage of carbon. Similarly, percentage of hydrogen equal to increases the weight of calcium chloride tube, weight of coal sample taken into 2 mass of the hydrogen, and 18 is the mass of molecular mass of the H2O into 100. We get the percentage of hydrogen present in the 1 gram of a coal. So next we go for nitrogen. So Jaldal Flask method. Jaldal Flask method. That method we are discussing in the intermediate second year. Jaldal Flask method. Okay, leave it here. 1 gram of coal is oxidized by heating with the concentrated H2SO4 along with the potassium sulfate and mercury sulfate. After the solution has cleared, treated with the excess of potassium hydroxide and ammonia. So it is liberated. So then the liberated product is washed with the distilled water and treated with known volume of distilled water. So here we see the percentage of nitrogen equal to volume of acid used into normality of acid by weight of the coal taken into 14 by 1000 into 100. So we calculate the percentage of nitrogen present in the coal sample. So next we calculate the sulfur content. So to determine the sulfur content in the coal, so by here it is determined from the washings obtained from the known mass of the coal used in bomb calorimeter for determination of calorific value. Especially we are using some instrument called bomb calorimeter to determine the sulfur content during the experiment. So sulfur is converted to sulfate. Sulfur is converted to sulfate. The washing when we use water, so that we cannot forget we are using washings. So the washings are treated with barium chloride to get precipitate barium sulfate. So it is filtered, washed, and heated to constant weight of we get barium sulfate. So that is the percentage of sulfur can be calculated easily. So percentage of sulfur equal to weight of barium sulfate by weight of the coal taken into 32 by 233 into let's we see here 32 by 233 into 100. So similarly we get the uh, percentage of sulfur in the coal. So similarly we get as and oxygen. So approximate analysis, we're getting the as content. Same we'll do here also. So finally, we are going to be calculate percentage of oxygen. Percentage of oxygen equal to 100 minus carbon plus hydrogen plus nitrogen plus sulfur and as. So we get the percentage of oxygen present in the we taken as a coal sample. So by using the ultimate analysis, we determine the content of elements. So we determine the content of elements like carbon, hydrogen, nitrogen, sulfur, oxygen and as. So by using these two analysis methods to determine the components existed in the coal. Next we go for significances of ultimate analysis. What are the significances of ultimate analysis? So let's see the significances. So carbon and hydrogen, higher the carbon and hydrogen percentage is better the quality of the coal and higher its calorific value. So we know that the composition or content of carbon is higher automatically, which produce higher calorific value. So nitrogen and oxygen can reduce the calorific value of a coil, hence it is undesirable. Nitrogen and oxygen which present in higher content, which forms undesirable compounds like toxic gases. So sulfur increases the calorific value, it corroded the equipment, so it is undesirable. So sulfur is also undesirable compound, which also forms acids while with washing liquids. So that's why here only we know that here the carbon and hydrogen in a higher content, which produces a higher calorific value. So remaining components which forms undesirable compounds, so which get decreases the calorific value, which get decreases the quality of the fuel. So these are the two methods we'll use it to determine the content of components existed in the fuel. So this is the fuel technology.